Hello, this is the third video of a first-order differential equation series for OCR Pure Core Further Mathematics, and it looks at the technique of separation of variables. Linear first-order differential equations can be written as dy by dx equals a function of xy. So f is a function of the variables x and y only. It is called linear because dy by dx is order 1, i.e. it's not squared or cubed, etc. And first order because it's dy by dx, not d squared y over dx squared, and so on. If the right-hand side can be written as the product of two separate functions, say g of x and h of y, then the equation can be solved using the method known as separating the variables. So let's have a quick look at these examples. Here we can see that we could take out the y factor as common and leaving us x squared plus 2x. Therefore that is indeed a function of y, h of y just being y, times a function of x. And therefore we could use this technique. In the second example, we are not able to separate the x squared plus y squared into a product. It is a sum. And therefore we cannot use this technique. In the third example, although we could expand sine x plus y into being sine x cos y plus cos x sine y, two products, those two products would be summed, and hence we cannot use the technique. You may already have come across this example, dy by dx equals y squared over x, in A-level mathematics. If we write this as being y squared times 1 over x, we can see that we have two separate functions, h of y and g of x. We can therefore write this as being 1 over y squared dy by dx equal to 1 over x. If we integrate both of these with respect to x, we can see that dy by dx times dx would actually be this equivalent to integrating by dy. Thus we can write that the integral minus 1 over y will equal log of x plus c. Rearranging this, we would find that y equals 1 over k minus natural log of x. Here is a second example. We can write this as being 1 over y multiplied by 1 over x. Using the same technique, therefore we would have y dy by dx equals 1 over x, and integrating both sides, remembering that we're integrating y with respect to y and the 1 over x with respect to x, would give us y squared over 2 equals the natural log of x plus c. Multiplying up by 2 would give us this, and we'll change that constant so that k is 2c, and therefore that y equals the square root of log, we can write it as x squared or as 2 ln x, doesn't really matter, plus k. The general case then is that if a differential equation can be written as dy by dx equals f of x times g of y, then we can divide by g of y to give 1 over g of y, dy by dx equals f of x. Integrating both sides, we note that if we integrate with respect to dx, that in effect we are then integrating 1 over gy with respect to dy, and that is equal to the integral of f of x with respect to dx. In the next video, we will look at applying this separation of variables method.